Under the canopy stands a tired F-16 with darkened skin and removed panels, next to which are tool carts, lifts, and boxes with markings. The team sets up supports, connects the power, lays out the drawings, and begins a calm resuscitation, where every step becomes a brick for the future resource. The hose is connected through the red fitting, energy is supplied, and the working fluids open the diagnostic channel. The board responds with short codes. The mechanic records the values and determines the order of work. First, the electrical system, then the hydraulics, then the power circuit. Under the fuselage, in the light of a lamp, traces of overheating are visible on the landing gear strut and small scratches. The mechanic checks the play and tightening torques, looks at the engine mounts and flap drives, and marks the inspection zones with arrows. They will return there with a torque wrench and an endoscope. There is no rush here because the cost of error is too high. The burnt-in inscription "Rescue" appears on the side. It is like the biography of the plane, and these traces are not hidden. They are studied under a magnifying glass, and a decision is made as to which sheets to remove completely and which to reinforce with overlays so that the new life of the unit will be longer than the previous one. The spars and stringers are stripped down to bare metal, etched, washed, and chemically protected. The panels are ground and measured with a thickness gauge. A series of rivets are seated tightly. The geometry returns to nominal value. There is no pathos here, only the dry mathematics of strength. The aircraft is disassembled down to the frame. The covers and cable harnesses are removed. The sections are labeled with tags. The engineers run a defect map, use ultrasound, eddy current, and penetrant testing where the red thread appears. There will be a cut and a new insert. The riveting pitch and edges match. The power circuit is again continuous. Two people are working on the edge of the wing, pulling the rivet gun from above, feeding the part from below. A dry click, and the element sits in place. A technician is entering the repair steps into a laptop nearby, monitoring the temperature of the adhesives. There is no need to rush, and you can't wait either. Each material has its own polymerization window. The cabin is empty, without a canopy and electrician's seat. Laying out new harnesses, labeling each connector, connecting data exchange units, and checking the starting circuit. Here, everything is similar to tuning an instrument, where each string must lie on its support, otherwise it will break during the first turn on. The engine is removed to a trolley and carefully moved like a heart before being examined on a stand. The parameters are measured at low and high speeds. The vibrations are compared with the standard. The exhaust gas temperature and oil pressure are checked. If the numbers are clear, the module is returned to the frame. If not, the cycle is continued until the cause is determined. The air intake is cleaned of sand and salt. The filter elements and seals are changed. The valves and shutoff mechanisms on the fuel supply line are checked. The system is flushed, and the pressure is maintained for a specified time. There should be no leaks. The hydraulic system is run through its circuits. The filters are changed. The lines are flushed. The working fluid is pumped in, and the air is removed. The steering gears are checked on a stand, and then the forces and speed of movement of the ailerons, stabilizer elevons, and fin are checked in situ. The gear ratios and centering are matched to the tolerance table. The chassis is completely overhauled. The struts are filled with nitrogen and brake oil. The discs and seals are replaced. The wheel bearings are lubricated, and the play is adjusted. Rolling out on jacks occurs without jerking. The position sensors give a smooth curve, which means the mechanics are healthy. Fresh ammunition with blue warheads lies on the table. These are training rounds, designed to produce recoil and tracer without fragmentation or flame. The team wearing gloves and goggles sorts the batches into lots, checks the markings and lot numbers, and inspects the primers and case length. If even one dimension is out of tolerance, the ammunition is rejected and returned for rework. Next, the belt machine is turned on, and a long, flexible, steel snake-like neck begins to slowly pull the links toward the aircraft's feed system receptacle. The speed is minimal to avoid damaging the projectile's drive bands and to ensure the belt lays smoothly in the correct sequence for the mission, which includes a tracer every few shots or a clean training burst to test the automatics. One soldier sits at the control panel and counts the pulses. The counter must show exactly the number specified in the technical specifications. Another monitors the weight of the box on the scale and the uniformity of the link pitch. A third pair of eyes checks the color codes to ensure no unnecessary parts make it onto the conveyor belt. Any click out of rhythm causes the machine to stop, because what they're looking at isn't just metal, but a weapon part that must function flawlessly. The finished belt is run through a receiver simulator, a blank cycle is performed, and each cartridge is checked to ensure it enters the port correctly without warping the head, scoring the case, and jamming the link lock. If the cycle is clear, the belt is removed and stacked accordion style in green boxes on foam inserts. A hygrometer indicates the humidity level, and the lid is marked with the batch date, ammunition type, and quantity. At the end, silence again. Only the gentle tapping of links against guides and the soft creaking of rollers. Someone wipes the table and pumps out the remaining grease. It's all simple and mundane, but it's here that the reliability of the shot is born, which the viewer later sees only as a brief flash in the frame. A little more paperwork and the green boxes are sent to a trolley, from there to the airfield, where the tape will be placed in the side and become part of the larger chain from preparation to takeoff.
I think what's best about this
now
job
the automatics will have a
in
smooth
the 309th is that it
won't fail at the most
offers
inopportune
how to
moment.
do this job.
The
You have to
sheathing
get
is
trained
returned
into
to
a
its
couple
place.
different career
Fresh
fields
primer is
to
laid
be able to
evenly.
perform this type
The
of
seams are
maintenance.
sealed with
And
sealant
so
where there was
it's really
corrosion.
the pinnacle
Smooth
of the
primer
is
applied.
that it's the
Then
variety.
a finishing
It's
layer.
never
and
really
new
doing the
marking
same
with a
job over
rescue
again,
arrow
and it's a
is
little bit slower
clearly read
paced.
as a
We're not
promise
on the
that the
flight line
emergency
trying to get a
panels
plane
will
up in
open
the air
when
right
needed.
away. We can
A
take our
long
time, make
series
sure
of
we do it
system
right,
tests
make sure the
begins.
plane is
The
100%
power is
that we
turned
go
on.
into.
The built-in
There's
control
always
is
some
launched.
scope of, well, we've never
The
done this
onboard
before,
computer
so
runs the sensors
figure it out.
and communication channels.
I love
the
doing
navigation
things
is
that are
synchronized.
out of
The
the
radio
normal
station
spec. I
receivers
love
are
figuring
set to
things out.
frequencies. The identification system responds normally. A short line appears on the screen. The test is passed, but this is only the beginning. Surface control is performed on jacks according to the rigging scheme. The leading and tracking edges move symmetrically. There is no play. The load balance is within limits. The flight control system records 0 points and stores the calibration in the memory.
So the
of the
Pantons,
units.
we started
Power
in
unit is
1917
assembled on site.
at Kelly Field.
All
That's an
lines,
awesome culture to be a part of. Yeah, literally everything you do is
are run through each
non-stop,
circuit.
push it up.
Each circuit is purged, kept under pressure, and graphs are taken. Leaks are not allowed.